What's up, aviators? Today we're reviewing a question that integrates a few of our ground skills. Given a true airspeed of 110 knots, wind 210 at 10, and a fuel burn of 9.5 gallons per hour, determine the magnetic heading and the fuel that we can expect to burn on a flight from Lake Chelan to Darlington. For the sake of this exercise, we assume we are already at altitude and don't plan on climbing or descending. First, we're going to take a look at our chart, identify our 2 points of interest, and draw a nice bold line connecting them. We find the point at which our course crosses a grid line and set the plotter or protractor so that those 0, 180 lines match up with the vertical lines of longitude, or the 090 and 270 lines line up with the horizontal lines of latitude. Make a note of the true course on your kneeboard. While we're here, let's determine the distance we need to travel. Be sure to identify the correct scale so you don't make a goofy error. Looks like 71 nautical miles to me. With our true course and distance noted, we turn to the wind side of the E6B. 210 at 10 knots, check. Next, we rotate the movable section of our true course of 290 and place our pencil mark on our true airspeed of 110 knots. Read the ground speed from the grommet, 107 knots. And it looks like we need a left wind correction angle of about 5 degrees, which gives us a heading of 285. Finally, take a look at our isogonic line for this part of our planet, and remember, east is least, west is best. We will need to subtract 16 degrees to obtain our magnetic heading of 269. This is the heading we will fly in the aircraft to reach our destination. Flipping back to the slide rule side, we take our ground speed of 107 knots, that's 107 nautical miles per hour, and set it against our 60-minute mark or our 1 hour mark. Remember that the outer scale goes up to 10 and the inner scale goes up to 60. Time is always on the inside. Find the 71 nautical mile mark, read the time in minutes, and use TLAR to decide if that checks. If we fly for 40 minutes at 107 knots, does 71 miles sound reasonable? That looks about right to me. The last step is rotating our rate arrow to 9.5 gallons per hour. Identify the 40-minute mark, and it looks like 6.35 to 6.4 gallons for this leg. And again, that looks about right. Alright, what do you think? Was this helpful? Let me know down in the comments. If you want to support me, check out my books on aviation down in the description. And if you're a pilot looking for some extra help, hit that subscribe button to fly my way. Thanks for watching. See ya.